Welcome to Management Sciences at Northwestern University. My name is Noshir Contractor. I'm on the faculty in Industrial Engineering and Management Sciences, and I'm going to share an overview of one aspect of what we mean by management sciences. You may have already heard from Syed Iravani about how management sciences involves the management of products and services, operations and logistics, for example. What I'm going to share with you today is a little bit about what we do in management sciences that involves the management of people, the management of teams, increasingly now the management of human robot teams, and the management of teams, or what we know as multi-team systems. There are three faculty members who work in this area: William White, Bill White on the left, myself, and we've been recently joined by Dashun Wang, who also has an appointment at the Kellogg School of Management. What do we do in management science? We focus on the impact of networks on performance as we reimagine the future of work. We use engineering and social scientific methods to explore how people's motivations and behaviors co-evolve with their performance in organizations. And this involves four aspects. First, the design and implementation of new technologies to understand and also to enable work. Three aspects of analytics, starting with descriptive analytics on the formation, maintenance, and the dissolution of networks. Predictive analytics, where we look at how these networks can predict performance. And then finally, prescriptive analytics, where we want to optimize performance within networks. The approach that we take is largely being shaped by computational social science. I was very privileged to be one of the co-authors of an article that appeared in Science magazine in 2009, where we began to introduce the idea of computational social science as a way of looking at social systems with really large amounts of data or using computational modeling tools. Again, almost a little over a decade later, we wrote another article that also appeared in Science this past year, and it talked about what we had accomplished in that first decade, as well as to identify obstacles and opportunities moving forward. I'm going to talk to you about two centers that we have at Northwestern affiliated with Industrial Engineering and Management Science. The first is the Center for Science and Science Innovation. This is a center that looks at the science behind science. How does science get done? And as you can see from this particular slide here, it has a website. It is funded by agencies such as the National Science Foundation, the National Institutes of Health, Sloan Foundation, as well as a big Minerva Research Initiative grant. This particular is headed up by Professor Dashun Wang. And so I'm just going to give you a quick overview of some of the things that Dashun does as part of that group. If you think about the science of science, it's been happening for a long time. Robert Merton talked about the Matthew effect. We talked about the invisible college of scientists. We've talked about who are the scientific elites. We've talked about changes in paradigms. We all may have heard about citation indices. So what is new? Why are we now interested again in science of science? It's very simply two things. One is that we now have massively available data sets, which we can look at. And the second is we have the availability of computational tools and techniques from AI, from network science and data science that allows us to take a new powerful look at what science, how science is being conducted and what makes for successful science. And as a result, you can see that Dashun Wang, along with his co-author Alberto Laszlo Barabasi, is publishing a book later this month called The Science of Science. Look for it on Amazon. And also has published review articles called Science of Science in Science magazine, and a more recent one called Toward a More Scientific Science. You can see that his work has been published in a lot of really top-notch journals, including Nature, Nature Physics, Nature Human Behavior, Nature Machine Intelligence, and a lot of his recent work is done in collaboration with an IEMS PhD student, Ian Yin. So again, there's a lot of interest in this area, a lot of excitement, and this is something that if it excites you, IEMS is a wonderful place to come. The next set of slides is going to talk about a center that I direct here called the Science of Networks and Communities, or SONIC for short. Like Dashun Center, our center is also very fortunate to have funding from a variety of agencies, including NASA, NIH, NSF, the Army Research Lab, and we've had funding in the past from the Bill and Melinda Gates Foundation, as well as Facebook and DARPA. So what does the Science of Networks and Communities Research Group do? We basically do three aspects of things. We talk about how we can take what we are studying and understanding network, and then see what we can do to make those networks better. Quite simply, we use a lot of different modeling tools, computational modeling, statistical modeling tools, to understand how networks form and then how those networks might perform. I'm now going to let you see a quick overview video that was taken of Sonic before the COVID crisis, and I hope you enjoy that.
Welcome to Sonic, the Science of Networks and Communities research group at Northwestern University. The core mission of Sonic is to understand and enable networks. In a wide variety of contexts, we look at theoretical premises that help us understand why networks form and how they perform.
I'm studying the pattern of scientific collaboration among researchers at Northwestern University. I use the theories and methods of social network analysis and graph mining to figure out how they collaborate and why some collaborations are successful.
There's an increasing prevalence of work being carried out in ad hoc, self-assembled teams. We use a tool developed here in Sonic called My Dream Team to investigate how teams assemble and also to enable the team assembly process.
Just as Match.com helps us find romantic partners in our personal life, the My Dream Team helps us find collaborators in our professional life.
I use text mining and social network analysis to investigate the design and structure of digital media to improve information sharing, performance outcomes, and team cohesion.
The rise of the web has led to growing interest in tapping into the wisdom of crowd and user-generated content. My research is developing theories to explain how networks influence the crowdsourcing of designing and reviewing creative products.
My research focuses on multi-team systems or teams of teams. I'm particularly interested in how relational dynamics unfold within these systems and how that impacts performance.
My research network is related with social movements and how they are performing in social media. Especially now, there are so many leaders and organizations who are performing their calls in these networks. So our interests are related with how leaders and organizations are performing in digital environments.
My research looks at how we can use transcripts of discussion to observe group dynamics. I use a combination of text and social network analysis to explore changes in group cohesion, hierarchy, and shared cognition.
At Sonic, my research focused on using network and computational methods to study the emergence of interdisciplinary fields such as oncofertility and implementation science. I'm also working on a project funded by the National Institutes of Health to see the impact of networks on the dynamics of the scientific workforce.
In addition to developing theories and methodologies that help us understand how networks form and perform, the Sonic Research Group is also committed to enabling these networks. In particular, we are developing socio-technical solutions that include software to help us assemble more effective teams, to help us understand who knows who and who knows who knows who, and to help us build scientific collaborations in a wide variety of contexts.
Welcome back. Now I'm going to talk to you a little bit about 5 research projects that are currently in activity in Sonic Research Group. The first one I'm going to talk about is very timely. It's about teaming in the times of COVID. This is a project that involves my collaborator, Leslie DeChurch, who's a professor of communication and psychology here at Northwestern. It involves Brennan Antone, who's a PhD student in IEMS, Jasmine, who's a PhD student in the Media Technology and Society program, and on the left there, Jacky Young Lane, who was an IEMS PhD student who worked with me. You would have, and you will hear more from her on a video later on. And she's currently doing a postdoc at Harvard Business School. So what is it that we are doing here? In this project, we are studying what networks looked like before COVID. We call that the old normal. We talk about what networks look like today in the new normal while we're in COVID. And we're trying to look and predict what's going to happen to networks in the workplace as we go to the next normal. We all know that working is not going to be the same as what it was before COVID. How is it going to change? And so we've spent a lot of time looking at a variety of different data sets and being able to study it both based on digital trace data as well as on survey data. Some of you may have seen this article. It says the alternative workplace, changing where and how people work, from sharing desks to working from home, etc. Now, what is interesting about this particular article that appeared in Harvard Business Review is that it was published in 1998. It could have been 2020, but no, this was in 1998, and people were beginning to see that the nature of work was changing. In fact, along with a former Northwestern IEMS faculty member, Paul Leonardi, we published an article a couple of years ago in Harvard Business Review, which was titled Better People Analytics. Quite simply, it said, we know a lot from networks and who people interact with in the workplace to be able to predict who will be coming up with good ideas, what are the signatures in networks that tell us who will influence whom, how can we detect whether a team would be efficient, whether a team would be innovative, whether an organization is siloed or an organization is vulnerable to external compromise. And so as part of this, one of the things we've been doing is to see the extent to which we can just take digital trace data from platforms like Slack, Microsoft Teams, Zoom that we're in right now, use that to predict what people would say on a survey when we ask them who they seek advice from, who they look to for leadership, who do they trust, and then use that to be able to unravel the signatures that I showed you on the previous slide. The next one is going to be about a project called Cruise. Here, I'm going to again introduce a video that'll tell you a little bit about what the Cruise project is and our excitement about space. So take a listen, and I'll be right back.
By the end of the 2030s, NASA wants to send a team of astronauts to Mars.
As NASA has begun to look at this challenge, they realize that in addition to the technological challenges and the physiological challenges of sending a manned mission to Mars, there are also psychological, sociological, and communication challenges that the team will face.
The crew will be in an isolated and confined environment for 2.5 years, something the size of a small studio apartment.
And these individuals are going to have to work together in very close quarters without the ability to suddenly decide that someone doesn't like their roommate and would like to have some time away.
Furthermore, as the spacecraft gets closer to Mars, the latency in communication means that it might be as much as 21 minutes before a message that is sent from Mars will be received back here on Earth.
This means that they're going to have to really act more autonomously than space crews have previously.
The scientific problem we're working on is figuring out what the factors that we can leverage are that will increase the likelihood that these 6 individuals can work as a dream team.
The name of the project is CRUISE. CRUISE stands for Crew Recommender for Effective Work in Space. And basically, it is a project that is focusing on how teams are composed and how the composition of that team is going to impact their performance over the course of the 3-year mission.
This is a 3-year multi-method project, and there's 3 primary phases. The first phase is a broad-scale data collection effort, where we collect as much data as possible to give us insights on how composition relates to team functioning in a context similar to long-duration space exploration.
We have been turning this literature into a theoretically supported agent-based model that allows us to run simulations and virtual experiments where we can manipulate different configurations of team members and look at the effects that it has on the level of cohesion that develops in the team.
One of the exciting opportunities that we have as part of these projects is to be able to collect data at a place called HERA, the Human Exploration Research Analog. This is a facility that is located at the Johnson Space Center in Houston and takes advantage of putting up to 4 people into an isolated and confined environment that simulates a space capsule, even though it is right here on Earth.
It's a 3-story, very small environment in which we bring 4 people in and they live there for 30 days. Next year it'll be 45 days, and they can't leave. They're also isolated and they can't use communications like the internet except to interact with mission control.
These individuals are doing teamwork tasks that have been carefully calibrated to provide us with moment-to-moment metrics of their individual performance, their mood states, their psychosocial adaptation to the experience of being in the habitat, their performance as a team, and their performance as a system of teams with mission control. The third phase of the project is to actually build a dashboard that is essentially the cruise model, where NASA can use this dashboard, input large repositories of prospective crew members, play forward the simulation, and have some predictions about which combinations of people are likely to be more and less effective working together in teams.
The importance of teams and the importance of understanding teamwork has been recognized by NASA. In fact, Scott Kelly, who is a NASA astronaut who returned recently from the International Space Station, said upon his arrival back to Earth that teamwork is what makes the dream work at NASA. And our research here is to help enhance the teamwork and help NASA make the dream work.
Welcome back. I hope you enjoyed that little video introduction to Cruise. Now what I'm going to tell you very quickly about Cruise is some more recent things that we are doing there. When we began to do this project, one of the things that we were challenged to do was to predict what would happen to people if we locked them up in small confined spaces for a large amount of time. And one of the ways we studied that process is by asking them who they would have gotten along well with. So this is actual network data that you're looking at, which we collected from a crew that was in an isolated, confined environment at the NASA Johnson Space Center for approximately 30 days, and in some cases now 45 days. And the green links say which astronaut crew member reported enjoying working effectively with the other people. But at the bottom, you see who said that they thought the others made tasks difficult to complete. And as you can see, the astronaut at the bottom here, everyone thinks that this astronaut is making tasks difficult to complete. And this astronaut has no idea that others feel that way. This person doesn't feel the same about others. Could we have predicted that one person would emerge as a hindrance in this particular case? And in order to do that, what we did was we created a computational model of crew relations, where we were trying to see the extent to which we will be able to predict whether someone was going to be a hindrance in the relationship. Once we got pretty good at that, then the question was, how can we then not only predict who is going to be good, but also be able to prevent that? So this is when we move from predictive analytics to prescriptive analytics. Basically, we were going to ask ourselves the question, which crew members should work together on highly interdependent tasks? In other words, what we were trying to say is, how could we repair groups members who had to work together in order to repair their relationships so that it's not so bad? And right now we're in the midst of a project where we've been very successful at being able to do exactly that. In fact, we have been just recently awarded a $1 million award from NASA to help them develop a dashboard that looks something like this, a tool for evaluating and mitigating space team risks that will be used by NASA as part of its Artemis mission to send the first woman and the next man back to the moon, and then on from there to Mars. The third project we are going to talk about very quickly is something called STRONG. This is about teams that involve both humans and robots. So this is an example of a team, our colleagues who are collaborating with us on this. I've already introduced you to Leslie DeChurch. I also want to introduce you to Aaron Schechter, who got his PhD in IEMS here at Northwestern, now on the faculty at the University of Georgia. You'll see a video from him shortly. And my colleague, Malte Young, who is at Cornell. Now what I'm going to do is say that what we're doing right now are experiments where we're putting people into rooms where they're working with a robot. And that name of that robot is Vero. And Vero is somebody that they interact with. And we are trying to understand, how does human-robot and human-human interactions change when one of your teammates is not a human, but a robot who talks to you? We introduce them to this robot as part of these experiments and then collect a lot of data to see their dynamics. And now what I'm going to show you is a brief video of what Vero looks like that we share with them. Take a listen. Vero will now act as your fourth teammate in the completion of the following tasks. Simply address and treat Vero as you would any of your other teammates. Vero has multiple voice patterns, accents, and inflections, and will converse, interject, discuss, and even debate like a person. Today, you'll be randomly assigned to one of our Vero voice settings. Just like people, Vero has some movements that indicate how Vero is feeling, what Vero is thinking, and when Vero is about to say something. A few of our potential Vero teammates will preview these signals now.
When I make this motion, it means I am idling and waiting for the next task to begin.
When I make this motion, it means I would like to speak, but I do not want to interrupt the current speaker.
When I make this motion, it means that I am speaking to you.
When I make this motion, it indicates that I am listening, attending to what is said, and I am deeply engaged in the conversation.
When I make this motion, it means I am waving at you to either say hello or goodbye.
Are you ready to meet Vero? Our next project that I'm going to introduce you to is titled A Hierarchical Multidimensional Network-Based Approach for Multi-Competitor Product Design. Here we are looking at networks, but we are applying network approaches not just to individuals, but individuals and their purchases of automobiles or other products like vacuum cleaners. And the reason is you can think of a network that involves at one level humans, which you can see on the top here. I should mention that this is in collaboration with a professor of mechanical engineering here at Northwestern. She's the chair of the mechanical engineering department, Wei Chen. She's also a very distinguished scholar and was recently inducted into the National Academy of Engineering. So Wei Chen and I have been working now for quite a while on this project where we have a network of individuals who may be interested in buying a car. We have a network of automobiles where some links between cars are situations where somebody may have considered one car but then ended up buying another car. Sometimes the network ties could be simply which cars were co-considered together. The two cars were both considered before one car was chosen. It could be association or similarities in features of cars, etc. And then the link between the humans and the cars are which cars were considered and which car was finally purchased. And then finally, the link amongst the people is the social networks where we talk to other people before we buy a car. And so this is an entire multidimensional network that we're using to see how well we can predict how people will make decisions about, especially about green cars, environmentally safe cars, electric cars, and so on and so forth. And then finally, very quickly, we also have a very robust active area of research in science of science, not unlike what Dashun and his colleagues are doing. And in our case, we are focusing much more on team science, the science of team science, looking specifically at teams. Here again, we are working with our colleague Alina Lungianu, who's on the faculty here at Northwestern, Griffin Weber, who's on the faculty at Harvard Medical School, and then Neela Modi, who is a PhD student here at IEMS. We are developing an understanding of what can predict whether a team that writes a paper will have a successful team, whether a team that writes a proposal will have a proposal that gets funded. And we have developed a platform called the Dream Team Recommender that we are actually using here at Northwestern in the medical school to help faculty and researchers in the medical school at Northwestern find out who they might want to collaborate with on projects in order to be able to submit grants to get money to support their research. And so here we are helping Northwestern researchers build dream teams, but in the process also understanding the science of who do they look for? What qualities are they looking for? Who do they end up inviting? Who accepts their invitation to join the team? And so on. These are some of the interfaces associated where they look for areas of expertise, and then they also look and say what kinds of pre-selected members they might want to have on the team. How many departments do they want? Do they have individual preferences of having people who have low seniority or high seniority? Sometimes you want low seniority because you want to mentor people, etc. And so this is again an example of where we are using technologies both to understand networks and enable networks. And then finally, we're also at a large scale looking at all the 6 million plus patents in the US Patent Office using text analytics to see to what extent, as you increase the size of a team, do you really increase the diversity in the team? We like to say that diverse teams are good, but what we find from the analysis here, for example, is that as team sizes, these are teams who put together patents, increase, the individual expertise of the team was not increasing linearly in terms of its diversity. as you began to add more people, you began to have more redundancy in expertise. And of course, that's not very good, because you know that a diversely expert team is one that's likely to be more innovative and come up with more creative patterns in this particular case. And you see, on the other hand, that there is always that the team expertise diversity is increasing across different areas of patents all the way from 1976 to 2018. So more and more people are forming diverse teams. And at the same time, we are seeing that those diverse teams have a sweet spot where after a period of size 12 or so, they are not increasing diversity as much. And recent graduates from the management science include Aaron Schechter, Jacky Lane, Sophia Sullivan, Mengxiao Zhu. You are now going to hear soon a video from each of them telling you about their own firsthand experiences here. And just to mention that these students do quite well when they graduate. You see both Aaron Schechter and Jacky Young won awards for their dissertations from prestigious places like the Interdisciplinary Network for Group Research on the left, the Hackman Dissertation Award, and Jacky was a finalist and won from the Academy of Management, from the Technology, Innovation, and Management group out there, etc. Again, I want to thank you very much. In addition to these students, we've also got funding for some of our current students who went and got their own external funding from NASA. Brennan Antone, who's a PhD student, is working on a NASA-funded grant that he received, and he's doing it under the guidance of myself and the chair of the department, Dave Morton. Nilufar Izzadinia also got funding from NASA independently and has been working on a project with our colleague Andreas Schechter here in IEMS, as well as Leslie DeChurch, who is in communication. So with that, I'm going to just thank you personally for listening to this presentation and leave it now with the testimonial videos that will follow on this. Thank you again.
Hi, my name is Jacky Ing Lane, and I am a graduate of the Northwestern Industrial Engineering and Management Sciences program, a PhD program in 2018. My research interests lie at the intersection of innovation, networks, and teams. And to give you a little bit of background, I first got interested in this area because I was doing some work with some online teams and online discussions. And this was about my third year of the PhD program when I stumbled across Professor Nishir Contractor's social networks class, which totally changed the way that I thought about teams and the connections and relationships that team members form with each other. My dissertation research was about leveraging different communication technologies, specifically social media, to potentially enhance teamwork. You know, I really enjoyed working on that dissertation. And part of that is because of the interdisciplinary aspect of the program and the people on my committee who really made the experience wonderful. And I think it also really set me up for where I am now. Today I am a postdoc at Harvard Business School at the Lab for Innovation Science at Harvard, which is actually a very interdisciplinary place itself. We have a team of people who are strategy scholars, economists, computer scientists, and I think having that interdisciplinary training at Northwestern really helped me appreciate this eclectic and interdisciplinary approach to research. Today, you know, I am still very fascinated with this world of online teams and virtual work. I still examine, and one of the things that has been ongoing work is together with Northwestern and with Professor Contractor and a team of other PIs. We are studying the impact of COVID on virtual teaming and worker productivity and performance as well. And so I am very excited about where this research will go in the future. So thank you.
Hi, my name is Mengxiao Zhu. I attended the PhD program at the IEMS department at Northwestern University from 2007 to 2012. After graduation, I worked as a postdoc at Rutgers University for 1 year, and then as a research scientist at Educational Testing Service for 7 years. I recently joined the University of Science and Technology of China, working as a distinguished research fellow at the School of Social Sciences. I really enjoyed and cherished the experience of studying and doing research at IEMS. IEMS provided very solid academic training to all graduate students in the program. The first year core courses covered many fundamental ones, such as statistics, optimization, stochastic processes, and stochastic simulation. Beyond the first year, there are more opportunities to take courses in the directions that you are interested in. My major area was in the direction of management science and computational social science. I got to take courses from both the IEMS department and the Kellogg School of Management. Besides courses, IEMS also offered a lot of opportunities for graduate students to get involved in doing research. I worked with Professor Nausha Contractor and was a member of the Sonic Lab. In one of the NSF-funded projects, I worked with big data from large-scale online games and analyzed the team formation mechanisms in the online environment. I also work on projects funded by the Chicago City and the Gates Foundation to study the real-world organizations and propagation of technology in developed countries. The training I received at IEMS is a very valuable asset for my career development and made me competent both as a researcher in industry and as a faculty node in academia.
Hi, my name is Aaron Schechter, and I was a graduate student in industrial engineering and management science at Northwestern from 2012 to 2017. Right now, I'm an assistant professor of management information systems at the Terry College of Business at the University of Georgia. I cannot say how much I enjoyed the industrial engineering program. It was hard at first, certainly the first year or so, but I was exposed to a variety of different classes from great professors. I got to explore my interests in both optimization, statistics, and also some organizational science. I had the opportunity to work with Dr. Nashir Contractor in the Sonic Lab, where I got to pursue my interest in networks and very early on get a start doing research. I would recommend this program to anybody who wants to build on their base in economics, math, computer science, or engineering, and either want to go into academia or industry. I feel like I was very well prepared to do research at a high level, and I was even able to cross disciplines to get a job in a business school rather than in an engineering school. Several of my friends also went to industry and were quite successful. Northwestern allows you the opportunity to move outside of the IEMS department as far as taking classes, getting research experiences, and meeting some of the other world-class faculty. I'd also recommend Northwestern because the campus experience, being in the city of Chicago, and just living in Evanston is a great experience. So all in all, I could not have imagined a better graduate school experience, and I would recommend it to anybody else.
Hi, everyone. My name is Sophia Sullivan. I started as a PhD student in the IEMS department in 2010, and I finished in 2014. After graduation, I went into industry in data science, and I've had several roles since then. My first role was at Think Big Analytics, which is an analytics consulting firm. My next role was at Starcom, which is a large marketing agency in Chicago. And currently, I'm the Senior Director of Data Science at Integra Credit, which is a fintech in the subprime lending space, also in Chicago. So when I went into the IEMS program, it was always my intention to go into industry and go into data science after graduation. And the department set me up for that really well. I was able to learn all of the methods that are important for data science, like machine learning, statistics, modeling, simulation, et cetera. And the department was also really supportive of me doing internships during the summers. That also set me up really well to go into industry. I really liked the variety of research that was being done within the department. And I also got to collaborate with other departments at Northwestern and other universities all over the country. So I got to learn about a lot of really interesting research areas. The program is definitely challenging, but it's worth it because of all the things you'll be able to learn, the people you'll be able to work with, and the opportunities that will be available to you after graduation, whether you decide to go into industry or academia.